Welcome to lesson 6.6. In this lesson, we're going to introduce a very new idea. I think this should be new to pretty much everyone, and that is called the determinant. Now, the determinant has to come first from a square matrix. If you have a 2 by 3 or a 3 by 4, a rectangular matrix, you cannot find the determinant. They have to be square. Now, the reason we talk about determinant is it's going to lead us to one more technique for solving systems of linear equations. This lesson 6.6 is our last method for solving systems of equations. In 6.7, we're going to do kind of an application problem with systems of equations. But here is our last let's learn another way how to solve this. Now, one quick note. There are two different ways that we can write determinant. You can use DET or you can use these straight bars. If you see either of those, that means find the determinant of the matrix. Now, let's talk about how to find that determinant. The determinant for a 2 by 2 is different than any other size. 3 by 3, 4 by 4, 5 by 5, all of that. A 2 by 2 determinant is quick and easy, and it is a simple formula that. AD minus BC. So we do AD, multiply the diagonal, subtract BC, multiply the diagonal. And that's the determinant of a 2 by 2 always. So if we look at example 1, if I wanted to call this A, B, C, and D, to calculate the determinant, I multiply the diagonal AD first, 4 times 1, and then I do subtract, and then I do the other diagonal multiplied. B, negative 3 times C, 2. So that gives me 4 minus a negative 6, which is 4 plus 6, which is 10. So we could say either the determinant of A equals 10, or we could write it with our straight bars, equals 10. But that's how you find a determinant of a 2 by 2. Like I said, pretty quick, pretty fast. 2 by 2s are not too bad. Now, one other note is last lesson, we learned this 2 by 2 inverse shortcut in class. We talked about how this shortcut only works for 2 by 2s, but we can now recognize that the denominator part of this shortcut is actually the determinant. So one reason a matrix doesn't have an inverse, like we saw in example last lesson, is if the determinant is 0. Because if the determinant is 0, then we're dividing by 0. Can't do that. The inverse doesn't exist. So determinant has to be a real number in order for the inverse to exist. So that is it for 2 by 2 matrix determinants. Not too bad, pretty quick and easy. Let's start to expand to a bigger matrix, n by n. Now for the rest of this lesson, we're going to focus on 3 by 3s. However, you do have a couple 4 by 4s in your homework as well. And the nice thing is the method that we're going to learn for 3 by 3s can be applied to 4 by 4s, 5 by 5s, 6 by 6s. They're all the same method. They just start to get more complicated, take a little bit longer because they're a bigger matrix. So this method of finding a determinant for a bigger matrix, 3 by 3, 4 by 4, 5 by 5, is called expansion by minors, or sometimes it's called expansion by cofactors. And here's how we are essentially going to do it. We're going to start by taking whatever size matrix we have, a 3 by 3, a 4 by 4, and even bigger. It works for any size you've got. And we're going to focus on this first row of signs. The other rows do come into play when you dive into more math, but for 1050's sake, we're just going to focus in on this first row of signs. You'll notice that no matter the size of the matrix, that first row just alternates starting with positive. Now, when we go to find a determinant of a bigger matrix, we're going to start by applying these signs to the first row of whatever matrix we're working with, no matter how big it is. So in example 2, I've got a 2 by 2. So I'm going to apply these signs, positive, negative, positive. That's my first row of signs for a 3 by 3. But if it was a 4 by 4, apply that row. If it was bigger, apply that row. So the first step, step 1, is to apply signs. Now, the next step is kind of fascinating. What we're going to do is we're going to take the 3 numbers in that first row that we've got, or more if it's a bigger matrix, and we're going to start to separate this problem. So I have a positive 3, that's my first one. I have a negative 1, that's my second one. And I have a positive 2, that's my third one. Now what I'm going to do is I'm going to take, so we're going to focus on the positive 3 first. I'm going to take that positive 3 and pretend to erase the row and column that that positive 3 is in. Then I'm going to find the determinant of what's left. So negative 1, 5, 1, 4. And that's the positive 3. Now that one's done. So now I can move on to the negative 1. Take out the row and column that the negative 1 is in, and we're going to find the determinant of the numbers that are left. And this is how we do a 4 by 4, 5 by 5, even bigger. You take out the row and column that it's in, and you find the determinant of the numbers that are left. So now let's do our last one, the positive 2. Take out the row and column that it's in. Find the determinant of what's left. You'll notice that I'm using my straight bars here to help me know that this is a determinant. Now I'm going to bring these a little closer together because this is all one equation, like this. So now I can take a positive 3, and in here I'm going to find the determinant of here. But hey, that's a 2 by 2. I know how to find the determinant of a 2 by 2. I got A, B, C, D. And I do my first diagonal. So negative 1 times 4 minus my second diagonal, 5 times 1. So this one, check. I found that determinant. I can calculate that all with a calculator now. Now I move on to my negative 1, and I find the determinant of this one. I'm going to start to go a little faster. So this diagonal first, 0 times 4 is 0, minus, then this diagonal, 2 times 5 is 10. And then I have my positive 2, and now I need to do this one. 0 times 1 is 0, minus, this diagonal, negative 1 times 2 is negative 2. And now I can start to simplify all this. So this is a negative 4 minus 5, which is a negative 9. This is a 0 minus 10, which is negative 10. And 0 minus a negative 2, which is a positive 2. So 3 times negative 9 is negative 27. Negative 1 times negative 10 is a positive 10. And a 2 times 2 is a 4. And negative 27 plus 10 plus 4 is negative 13. So there's your determinant of your 3 by 3. So step 1, we applied the signs. Step 2, we canceled the rows and column right here to get the remaining determinants. And then step 3, we calculated determinants from there. And that's how we take a 3 by 3 determinant. Now you can see how this process gets a little more complicated with a 4 by 4. Let me show you real quick right here. Let's say I have a 4 by 4. We would still apply the signs to our first row. And then we would still separate it out. And then we would still cancel our rows and columns. So this one I'd cancel those two, and I'd end up with 6, 7, 8, 10, 11, 12, 14, 15, 16. And then I could erase those two. Next I'd cancel those two and get 5, 7, 8, 9, 11, 12, 13, 15, 16, and so on and so forth. Keep doing that process for the other two. And then now we have a 3 by 3, so now we need to do it again. Do our plus, minus, plus, and we'd have another layer. So we'd have this positive 1, oops, and then we'd have a positive 6 with a determinant, a negative 7 with a determinant, and a positive 8 with a determinant. And we do our canceling again. Cancel those 6, so we'd get 11, 12, 15, 16. Cancel the next two to get 10, 12, 14, 16. And now that they're down to a 2 by 2, you can do the AD minus BC and calculate all of that for each one. So it's definitely a longer process, but that's how you do it. It's the same process. We're just applying it to steadily bigger and bigger matrices. Now, the last thing I would like to cover in this video is that 3 by 3 determinants do also have a second method. I wouldn't necessarily call this method a shortcut, it's just different. However, this method for determinants only works for 3 by 3s. If you have a 4 by 4, 5 by 5, any bigger, you have to do it using this method. That is the only way we can. If it's a 3 by 3, there is a second method you can use. If you don't like this one, you can use this method right here. It's called the diagonals method. And what we're going to do is we're going to take our matrix, and then we're going to repeat the first two columns. So notice I took these first two columns and then I repeated them. And then we're going to multiply and add the diagonals, kind of like we did with the 2 by 2. So I take this diagonal first, A, E, I, multiply those numbers together, and then I plus, multiply those numbers together, and then I plus, multiply those numbers together. Then I subtract, and I do the other diagonal. So GEC multiplied together plus HFA multiplied together plus IDB multiplied together. So you can use this method and it will get you the same exact answer as this. However, remember, this only works on 3 by 3s, nothing bigger. So what I'd like you to do last is take this matrix here, the same one that we started with, 3, 1, 2, 0, negative 1, 5, 2, 1, 4. Repeat the first two columns, and then try to apply this method to this 3 by 3. You should still get negative 13. That should still be your answer. This is just a different way of going about it. So pause the video, try that one out on your own, and then come back to check your work. Let's see how you did. I tried to color code some of this so that hopefully you can follow my work a little bit better. But I got the diagonals each here with their color. I added the diagonals that go down, and then I subtracted the diagonals that go up. That's how the formula works. And then I just simplified from there, and I did get the same answer as up above, negative 13. So when it comes to 3 by 3 determinants, you can either use expansion by minors, this method with the little signs and the canceling out, or you could add the second two rows and use this method, the diagonals method. Both will get you the same answer. If you have a bigger matrix, 4 by 4, 5 by 5, you have to use expansion by minors. That's the only option we've got. So that is a little bit about determinants. We now know how to calculate them. We can calculate a 2 by 2 using our formula, and we can do 3 by 3s using either of these methods, and we've introduced how to do bigger ones using expansion by minors. In the next video, we're going to use determinants to solve systems of equations using something called Cramer's method. I'll see you there.